Hi everyone! Today we're going to dip into the fascinating world of physics, so stay with me to know more about the Higgs particle and the importance of the Large Hadron Collider in this story. I am Samantha Villalobos and welcome to my blog. So first of all, I want to clarify that this video is based on an essay that I wrote when I was in 10th grade, and this essay was about this book that is called The Higgs, the Liquid Universe, and the Large Hadron Collider. I recommended it 100% because it's one of my favorite books, and every time I read it, I learn something new. It talks about a lot of theories in the physics and a lot of concepts that are important to know. So before I start explaining all of that, we have to know that there are four fundamental forces in the nature that are the electromagnetic, the gravitational, the strong, and the weak force. These forces are so important because they describe how the particles and everything behaves in our universe. So, for example, the electromagnetic force is the one that describes that when two particles have the same charge, they will repulse each other. But with the strong force, they could stay together, like the protons that have the same charge, they could stay together in a nucleus of an atom. Knowing that, here we have the standard model. That is the model that explains 3 out of the 4 fundamental forces in the nature, excluding gravity. And this is because the standard model describes the particles in a microscopic scale, and here the gravity has a minimal impact. But this model is very, very important because so we can know how Universo is composed. And the standard model shows that the matter is made by elementary particles, and these elementary particles are divided into quarks, leptons, and bosons, which is surprising because the electrons are actually leptons and the protons and neutrons are made by quarks. So we can create atoms with these 3 particles. The bosons, by the other hand, are the particles that mediate the interactions between the particles. For example, the photons, that are a type of boson, mediate interactions of electromagnetic interactions. The gluons mediate interactions of strong forces, and the W and the Z bosons mediate the interactions of the weak forces. But the problem here is that we are searching for a theory that describes everything, where all 4 forces are included. And the standard model is a good candidate for the theory of everything, but it has the problem that it puts the photons and gluons on the same level as the W and Z particles, even though that the gluons and photon has no mass, and the W and Z particles are extremely heavy. And because without the integration of gravity in these models, concepts like the Big Bang or black holes are still incomprehensible. That is why the Higgs mechanism was developed. Here is where the relativistic quantum theory takes a big role, because as we know, the quantum theory explains the atomic world, while the relativity focuses on a macroscopic scale. So to solve the aforementioned problem, the relativistic quantum theory begins. This theory says that the true empty space does not exist. So we all know that in the space is full of galaxies, planets, stars, and so a lot of other things. But there's a lot of empty space between those galaxies that does not have nothing. But this theory says that in this empty space, a lot of particles and antiparticles are appearing in every moment, but they are so quick, they disappear so quickly that they aren't even real. They are called virtual particles. But this idea was so weird and it seemed impossible until the lamp experiment was made. And in this experiment, it is shown that the orbit of the electrons have a little shift. And this shift could be caused because of the constant appearing and disappearing of the particles and antiparticles. This experiment measured the shift and explained that the particles can be created out of nothing. And this means that the universe maybe was created out of nothing. And this was a huge change in the thinking of the physicist because, as we know, the physics law says that the energy could not be created or destroyed, it just being transformed. And this new theory says that the energy came from the nothing. And this is why the Higgs mechanism is so important, because in the Higgs field, the particles have a mass, and this Higgs field will not disappear in the lowest energy, like in the empty spaces, because it is a scalar with no determined direction. And like in the vector field that it has a lot of direction, this Higgs field does not have a direction, and you can imagine it as a cocktail party of workers that are discussing and are distributed uniformly. And then the prime minister enters. This is an allegory that was created by Miller, and he explains that when the prime minister enters this cocktail party, the people gather around him, so it creates resistance to movement, that is the mass. This makes possible that the particles that mediate the weak interactions can have mass, while the other bosons that mediate the other interactions, like photons or gluons, does not have mass, because they don't have this resistance to movement. On the other hand, the Higgs boson is more like a wave that is spreading around in the Higgs field. You can imagine it as a rumor that when some worker hear the rumor, it's going to be spread through the room in the whole party. However, this concept wasn't convincing enough until the discovery of the Higgs particle in 2012 in the LHC, the Large Hadron Collider. In this collider, what happened is that they put these proton beams traveling in opposite directions, so in a very, very high speed, so that they can study the results of the collision. And one of the results was this Higgs particle. In conclusion, the LHC helped us discover the mysteries of our universe and the mysteries of modern physics, so that is why it is a very important part of physics. And it helped us demonstrate with this discovery of the Higgs particle a part of the relativistic quantum theory. What we can say, we live in a universe full of possibilities, and the technology is advancing so rapidly that we can even see the universe condition in its first millisecond of existence, which is generally surprising. So that's all for today, and if you want to know more about this topic and everything, I will make another video soon. Just let me know in the comments, and there's a lot more to say. I will be generally very excited to talk more about and investigate more about this.